My name is Nolan S. Code. I reside in Atlanta, Georgia, not too far from where the Atlanta Braves play. Screw them, though, go Mets. And I am from New York City, Queens, New York, to be specific. Uh, as you can see, that's the title of the presentation of what we're going to get into today. I just wanted to say, though, that quantum isn't just faster computing, it's a new way of reasoning, innovating, and collaborating. I just talked about grad school just a second ago, Southern Methodist University. That I found out through the job, and I went through it and was going through the classes, NOP and cybersecurity and stuff like that. And it was quite boring, to be honest with you. And I spent most of my time arguing with professors with superior logic. However, I came across quantum computing, and I said, "This is interesting," and it made me work backwards, as my AWS friends would say, right? I realized that physics is the foundation of all sciences. And it made sense to me, right? Because I had always been good at math, but not until college. Shout out to Reverend Norris at Morehouse College, who is still teaching apparently. But I was always good at the math. I could do multiplication in my head, and that's fractions, right? And that leads to algebra, which leads to calculus, which leads to physics, right? And pardon me, I'm an ex architect. I think of everything as like a tech stack. So when I think about it, physics is the foundation, and then you build upon that with chemistry, biology, so on and so forth. And so really was just each was just a new rung to unlocking the way that you see the world. So going on to this, let me move this box over here so I can see. All right. So we have at the top Isaac Newton, largely considered to be the father of physics. I disagree, but whatever. Uh, truth is ever to be found in simplicity, and being below that, you have Max Planck, largely considered the father of quantum mechanics. He said, when you change the way you look at things, the things you look at change. Now, call me a homer. I don't care. I am a man of Massey. He was president of Morehouse College when I was there, and he's also world renowned in the physics world. It's a shame I only got to meet him once, and that was when he was handing me my degree. But he came across a quote that I thought that was interesting. That basically, like, uh, science needs to make people's lives simpler, right? And that's what we're going to talk about today: simplicity, perspective, and making science serve people. Occam's razor, if anybody's familiar with that, right? Taking the simplest way possible, if at all available. So let's look at what we're going to go on today on our path. We're going to talk about fundamentals of quantum computing, algorithms, Microsoft's role in it, use cases in chemistry and finance, prospects and applications, careers in investing, social good, and finally, vision. Now, the question you're probably asking yourself, why should I even listen to this guy? Everything, if you take one thing away from this, it's that always be intellectually curious, right? That curiosity started in my what, mid 40s, right? With physics and engineering. I only took that one class in summer school in Morehouse more than 20 years ago. And then that curiosity led into business. I have an MBA from Georgia Tech and now a Master of Science and Computer with an AI focus that we talked about earlier. And now I'm bridging all that with AI quantum and high performing computers, which we will now refer to as HPC for short. And Microsoft, and more importantly to me than anything, is supporting students and startups to build what next, because we need to get our kids involved in the physics. I want to be clear, I'm talking about Black people, right? Like my professors used to tell me at Morehouse, and I've been screaming for years that we need more AI researchers, and I feel like the best way to do that is to get a good foundation in physics and have an engineering mindset. I have far surpassed anything that I ever thought I can do in the industry, and now it's time to pay it forward to the next generation. So let's get into some fundamentals. And let's also hope that this sound works. All right. So let me move this over. When I first heard about all this quantum computing, I thought it was like one of my favorite shows from back in the day, Quantum Leap, right? Portals and chambers and uh, all these desperate things like that. And no, it's not really that elaborate. So think of a, I hate saying classical computer, but it just serves the purpose. A bit in a classical computer as ones and zeros, right? It's like a penny lying flat, heads or tails. Now, a qubit, known as a quantum bit for short, is like a penny spinning, heads and tails, both at the same time. Hopefully that metaphor kicks in. If not, I have something else on the next slide that I think that will hit it. I think I heard there was some chemistry majors, some other science majors back there. Uh, Qubits are basically like wave functions, right? Probability clouds, and each has a wavelength. By tuning the wavelength, we change the behavior. It's like tuning a radio, right? Each frequency gives a different station. If any of you come from the world of AI, it's like fine tuning a model, right? You're adjusting the parameters until it behaves how you want. The only difference is these parameters are physical waves. Now, something else I want to get into before we move on is quantum supremacy. And that's basically a milestone when a quantum machine solves something that no classical computer can. Google claimed that they did it in 2019, but they lied. IBM pushed back, and Microsoft bets on Marjana, which we're going to see in the next slide. And startups like IonQ and Rigetti are racing, but whoever wins defines the next era of computing, period. And that's why so many folks are investing so much resources into it, including time and effort. If you want my personal opinion, I think my old buddies in Beijing are going to win because how are you going to beat an entire nation? So quantum is powerful, but it's uncertain, right? The thing that blew my mind, we're gonna go into the use case later. The thing that blew my mind is with so much physics going on.
Like feature by feature.
Is someone saying something? No? Okay. Uh, but it's sort of entanglement that makes the qubits computational power rise, right? And basically, that's when the qubits going away to where you can predict. Let's say it's still that coin, right? You know that tail, if it's heads, it's automatically going to be tails, right? And that's what I mean by here, down here, by teamwork of the effect of the qubits and sort of that unison, so to speak. Uh, so I'm gonna move on, but and first of all, let me apologize. Number one, I'm a YouTube guy. I love them so much. I don't care whether it's another company or not. I told them when they came down here to Atlanta at the gathering spot how much I love them. And so I had premium, but this might bring up an ad, and but it's so good and so short. I wanted to bring it up. And number two, have I found a soulmate in Justin Trudeau? Because I've never seen someone besides myself get so excited about quantum computing. So here goes. I'm going to unmute it. I can see that now.
Pardon me, we can't hear the video.
Oh, you can't hear it?
Yeah, if there's something playing, we can't hear it.
Oh, goodness. It's okay. It was just him talking about
Could you put the
quantum.
link in the chat for us, please?
Yeah,
We
yeah,
could
yeah,
do it
yeah,
later.
yeah, for sure. And by the way, I'll put it in there, but that bothers me because you really need to see or hear what's going on in the next slide.
If you
Well,
stop sharing and reshare, there's a button that says share sound and it should play.
okay.
Yeah, it'll be at the top of your screen.
Let's see. And pardon me, folks. As you can imagine, I don't use Zoom much. No, not there yet. Let's see. And then it just, oh, here it is. I see it now. There you go. Thanks, folks. All right.
Teamwork.
Yep, teamwork makes the dream work. I heard drill sergeants yelling that at me many times. Let's see if we can hear old Justin now.
The interim while we prepare.
Okay. Very simply, normal computers work by.
Can you hear it? Yes? Okay.
Yes.
Let me know, Melissa. I can only see you.
Don't interrupt me. When you walk out of here, you will know more. Well, no, some of you will know far less about quantum computing, but most of you, normal computers work either there's power going through a wire or not. It's 1 or a 0. They're binary systems. What quantum states allow for is much more complex information to be encoded into a single bit. Regular computer bit is either a 1 or a 0, on or off. A quantum state can be much more complex than that because, as we know, things can be both particle and wave at the same times, and the uncertainty around quantum states allows us to encode more information into a much smaller computer. So that's what's exciting about quantum computing, and that's what we're going. Don't get me going on this, or we'll be here all day. Trust me.
That's literally how I felt the first time I found out about quantum computing. It makes me really think about our leadership here in this country. But moving on, the fundamentals of quantum mechanics. Now, what's interesting about this to me is, number one, it's just super cool. You'll just see it in a second. But because of the instability of the qubits, you have to keep it cold, so cold that it's in cryogenic chambers. And also how they were able to fit this many qubits in this small amount of hardware. And I'm not just saying that because I'm a homer. Yeah, I think it's very impressive. Let's see.
This chamber is the coldest place in the known universe. More than 40 times colder than interstellar space, but what's it actually cooling? Last week I got a call from Microsoft.
I can't really share much on the phone, but we have something pretty incredible coming up that I think you'll want to see.
Next thing I knew, I was on a plane to Seattle, hopping into a car, and before I knew it, inside a lab at an undisclosed location. It was here that I finally got to see what this was all about. It was here that I got to see the Majorana 1, Microsoft's extreme breakthrough in quantum computing and the result of nearly 20 years of hard work. This team was able to control a subatomic particle that was only theorized until now, creating an entirely new material and a new architecture for quantum computing that's able to fit 1 million qubits onto this little chip.
This thing will have more computational power in it than all the combined computational power in the planet.
Okay, but what does this actually mean? Well, a normal computer can only process things in bits, basically ones or zeros, whereas a quantum computer uses qubits that can be both in that 1 and 0 state at the exact same time. Imagine a maze. A computer mouse has to go in each direction one at a time to find the end. But a quantum mouse can go in all directions at the same time. The more qubits you have, the more quantum mice you have that can explore these exponentially many paths at the same time, solving the maze much, much faster. To put this all in perspective, the largest quantum computer that we have right now has a little over 1,000 qubits, and to expand this, it would take up football fields of space. But this new Majorana 1 chip will be able to house 1 million qubits in the palm of your hand.
All right. So before we move on and I start doing a duo with my cybersecurity folks, let me stop there because I've thrown a lot at you. Do we have any questions? Brevity folks, do we have any questions in the chat? Which I've totally lost control of. There's so many messages in there at this point. If not, we'll roll on.
I have a question.
Go ahead.
Hi. So, are you saying that the normal computer uses zeros and ones, like not at the same time, but with quantum leap, you're using the zeros and ones at the same time in a cubic or whatever
Correct.
you just said? Okay.
Yes, yes, and so per that last video, I think the mouse example was really, really good. But to answer, I think the crux of your question,
Mm-hmm.
it's binary, right? On or off, yes or no,
Right.
heads or tails, right?
Mm-hmm.
Yes.
Hi, can I add something? I was listening to you guys. Have you guys heard of the double slit experiment?
I apologize. I can't hear that person very well.
I think she said
Have
double
you?
split.
asking if we've heard of the double split experiment.
Yes, the double slit experiment. Because Justin Trudeau, he talked about the waves and the particles. And so would this be something similar like what quantum technology is? Is it sort of wrapping the double slit experiment into technology in a sense?
The way I'm more well, first of all, let me double back for a second. In the chat, I think I only put one YouTube video in there. And that is of my soon-to-be brother-in-law, Dr. Thomas Searles in London. He's giving a speech about quantum physics and quantum mechanics in a little bit deeper detail. So you might want to check that out. And secondly, the way I think about it is almost like yes, but like the wave particle you have to control, right? And then two, you can and I look at things from an AI perspective, right? Because that's still what I do. It's almost like almost trying to land a note on a music scale, right? And until you can do that properly, it's going to be unstable and go everywhere, basically. And I'm referring to qubits when I say it. But I'm going to look deeper into the specific experiment that you're referring to and get back to you, or at least ask around to some of the professor folks.
I got a question. My name is Luanda Quint. How are you doing?
I'm good. But hold on for a second. We have to move on just because of time's sake. I'm sorry.
Just a quick question. Just a quick question.
All
Not
right.
long. I'm a chemist and I'm a software engineer. I've did chemistry for years. When do you think a commercially available quantum PC will be available for the regular people, if at all possible? You know, it's quite expensive and technologically advanced.
That is so far from a simple question. Some people feel like it's never going to be in our lifetime. Some people say 20 years, right? To your larger point, right? We're getting into the realm of sort of like oligarchies, basically. Right. And because it takes so much compute, resource, time, and power, they have the major advantages. It's interesting when even following like an IonQ or Rigetti or some of these other startups, how much ground they've been even able to make because of some of the behemoths and the resources that they're facing. So there's no set time period on when there'll be a commercially available quantum computer for everyone. Right now, as we'll get into in some of the later slides, you have to sort of lease it out through Azure or whoever it is that you're using via the cloud. You
I
could
say
do it
so.
locally too, but that's going
Can't
to take up a
can't
lot of
can't
usage.
quantify it with the Moore's law. You're saying when it comes down to it.
Absolutely, absolutely not, right? Because I was thinking about that the other day with GPUs. It's definitely not following Moore's law, right? Because if you think about it, economics wise, it's being manipulated because it's being hoarded by Elon Musk and co, right? Who just reached $500 billion I saw today. My goodness. And others who are hoarding the GPUs, right? So that's manipulating the market. So we can't advance every 2 years, right? Or expand exponentially every 2 years. All right. So development and overview of Shor's algorithm. This is where I'm going to back up for a second. We said we had some cybersecurity folks in here. At least I thought I heard that in the beginning.
I'm a Microsoft system admin and Azure architect, so I'm borderline cybersecurity.
Okay. Well,
I was
let's
a
talk
part
about.
of I was a part of the emerging student leadership college program at Microsoft.
Okay. So
I used to work in cyber. I used to be at Meta as a director, security.
got it.
I
Got
was
it.
also at Accenture, as a leader over there.
Did
Focusing.
you? Yes, it sounds like you know what you're talking about. Can you discuss Shor's algorithm a little bit?
The most efficient thing for me to do is probably Google it, right? I mean, I can, you know, I'm not the
Let
most
me, let, yeah,
sending
yeah.
question.
Let me try. All right. So the reason why quantum came into my purview in the first place is in doing this for 8 years as a consultant, architect, yada yada. We always talk about data encryption, right? All the time, right? You stress it, the bad guys get a hold of it, they can't see what you're doing, encrypting your data at rest, encrypting your data at transit, so on and so forth. And then I learned about this, and basically in 1994, Peter Shor makes an algorithm that says that you can factor numbers exponentially faster that cracks RSA, right? Basically the backbone of cybersecurity. So think about it as like a safe with billions of keys, and Shor shrinks it to like a handful. And that's why I feel like post-quantum cryptography is so urgent now. And that's why I was asking who's in cybersecurity, because I feel like for the past couple of years, we've been kind of kicking the can down the road. And now that time has come. And at least from the people that I probe in the massive security company portion of Microsoft now, they're kind of like scrambling, basically. The slide that we're talking about now is going over some of the things that we talked about, how encryption is so reliant upon RSA, and how something seemingly overnight that we've known about for 30 years can come and change that. Did someone have a question? Okay.
Yeah, I did. I did. So I'm kind of getting into NVIDIA in regards to their quantum computing processors. Um, have you researched that piece?
That's a little different and off topic for what we're talking about here, but
Gotcha.
I have right, because when I'm not even going to get into that, because if I start getting into all these shady Middle East deals, we'll be veering off into another discussion. But yes, I have to answer the question. All right, so basically, to sum it up, Shor's algorithm, large numbers that get undermined, the sort of the classical public key cryptography. If there's any architects out there, right? The threat and how we need to do something about it right now. And now governments especially are not starting to take things seriously. Quantum safe cryptography, basically, right? Has emerged. Now, let's do some shilling for the company. How is Microsoft involved? So we don't look at sort of quantum as a silo, right? Because the future isn't pure quantum, right? It's AI mixed with high performing computers with quantum, right? And if you think about it, and we'll see it more in the use case, but you're looking for a needle in the haystack, and basically the AI is guiding you to the needle, right? And the use case to me is just fantastic because well, we'll get to that in a second. Let's do some more shilling. Basically, you can lease out Azure Quantum from Microsoft Azure right now in one unified platform. And as somebody who has wrecked SMU's HPCs in the past, it can get expensive very fast. So it's good that everything is involved in one. So one of the things I was asked is, how do I get started in quantum, right? Because there is a language, Q Sharp, and there is a kit QDK. I'm going to let a colleague talk about this for a little bit. I think I put one of the links in the chat already. If you go all the way to the top, there's like my resources of that I provided. One is through IBM where you can get started. One is through Microsoft where you can get started. The YouTube video and the financial use case.
Hi, I'm Mina Starks, an engineer on the Azure Quantum Development Kit, or QDK. Let's take a quick tour of what makes the QDK a great platform for learning and exploring quantum computing. Q# is a programming language specifically designed for quantum computing. It combines classical elements like for loops and function calls with quantum-specific constructs. This mix of classical and quantum features allows you to naturally express adaptive algorithms and lets you reason about the whole program without context switching. Once your Q# code is ready, you can test it locally with our efficient quantum simulator, which helps you iterate quickly before running on actual quantum hardware. There are also sample programs like Grover's search and Shor's algorithm to help you get started. Our debugger is a powerful tool that lets you step through your code line by line, inspect the quantum state, and view an evolving circuit diagram so you can debug even complex algorithms. When you're ready to run on real quantum hardware, you can submit your Q# code directly from VS Code to Azure Quantum, where you can choose your hardware and download results when the job is complete. For larger, more complex algorithms, resource estimation helps you understand the physical resources needed to run them, so you can optimize and make trade-offs between resource use and runtime. And for Python fans, the QDK includes a Q# library, letting you run Q# code from Jupyter notebooks and combine it seamlessly with Python. The easiest way to try out the QDK is by installing the VS Code extension, or jumping right into the Q# playground to experiment with sample programs. Happy quantum coding!
So before we move on to the use case, do we have any? Well, no. Let's keep pushing. I'll stop for questions after the section ends. So, one thing I forgot to put in the chat was a link to the book Atlas of AI. I would definitely recommend reading it because it shows you how devastating mining for lithium is all over the world. Lithium powers every phone, laptop, electric vehicle, but it has to come from somewhere, right? It has so far devastated ecosystems in Chile, Bolivia, Argentina, and if you read the book, right here in Nevada, in America. So at the Azure Quantum team plus AI and HPC discovered new lithium compounds digitally, right? So like I was talking about before, the AI acted as a flashlight. The HPC crunched the data, right? And it was like a tracker, and the quantum was like a microscope. In my opinion, this is Nobel Prize level work, right? Discovering batteries basically from math and not minds. And it's fascinating to me. So the video I'm about to show is how this partnership and collaboration came about. It'll be the last video because I'm not on the Azure Quantum team. My client is the United Nations. And when the World Bank came calling for quantum, I felt like all this preparation made me ready. So here we go.
Imagine if every scientist had access to their very own personalized supercomputer. How much faster could they go? How much further would they get? At Microsoft, we're actually doing it. We're co-innovating with the world's leading scientific institutions like Pacific Northwest National Laboratory to reduce the impact of climate change, get to net zero emissions, and find new ways to create, to store, and use energy more efficiently.
We're joining forces with Microsoft to explore this convergence of artificial intelligence, high-performance computing in the cloud. And this is a shift that the world of science hasn't seen since really the dawn of supercomputing. And for us, it's helping us tackle these challenges in chemistry and material science that are embedded in the search for new energy storage solutions that the world needs.
My name is Vijay Murugesan. I'm a material scientist here in Pacific Northwest National Lab. My research is mostly focused on designing next generation battery materials. Electricity generation needs to be renewable energy, but the renewable energy is not constant. It's sporadic, right? There's a lot of rain, or there's no sun, a lot of winds. Battery gives you an opportunity to store energy in a compact way and deliver it whenever, however you want.
Microsoft was really excited to work deeply with an organization that has strong roots in chemistry, material science, and how those disciplines relate to sustainability. Our goal was to work with PNNL to take the burden of exploring vast chemical or material spaces. Computational tools allow us to put the emphasis in the most promising parts of that discovery process. That's going to require a new way of doing chemistry that's computation first. Our team discovered a new electrolyte that uses 70% less lithium than shown in other industry announcements, because it replaces part of it with the earth-abundant compound, sodium. Azure Quantum Elements accelerated the initial phase of the discovery process. It took what would have been 20 years of computation and compressed it down into 1 week to identify the most promising candidates for later exploration.
Battery has a multiple components. You are trying to put completely different type of materials together, and then you are asking them to work together as a synergetically. One part of the battery is called the lithium ion. Lithium is fast, and its ability to move even within solids is what makes lithium more attractive. But lithium is not something that you can easily go and dig it up. It's only available in certain geopolitical places. What the scientists have been thinking about is that how can we make it to the next stage, right? Can we use something else that can work as good as lithium, but without the baggage of their environmental and safety issues?
Tackling this approach through the traditional trial and error method is simply too time consuming. The ability to narrow down the playing field from millions of potential combinations of elements and structures to dozens in just months, something that would have taken decades. The acceleration aspect of this can't be understated.
This co-innovation model has the potential to transform every discovery-based field. Chemistry and material science impact nearly all manufactured goods. So think of areas like pharma, life sciences, transportation, manufacturing. All of it is in play.
What we're most excited about at Pacific Northwest National Laboratory in this partnership with Microsoft is the opportunity to accelerate scientific discovery, not just in chemistry and material science. This is just where we're starting. When you think about the convergence of artificial intelligence models coupled with high-performance computing in the cloud, running alongside of co-pilots that are trained in specific scientific disciplines, and having all of that come to bear at the disposal of the individual researcher or the scientist, that's a paradigm shift.
I just want to make sure that everybody understood what we just saw. We're basically making lithium out of nothing, right? And not only is the mining for lithium horrible, let's just call it what it is, but then it has to be disposed of eventually, right? And where does that go? Ask our brothers over there in Ghana and other places like that. So before I move on, the root of one question was basically quantum hype, right? You'll hear people say quantum's hype. NVIDIA was brought up once by our favorite rock star CEO, right? Jensen Huang. And I get it, right? Skepticism is healthy, but here's the truth. If it were only hype, why are Microsoft, Google, IBM, and entire nations like China pouring billions of dollars into it? You don't build 100 qubit system or natural program for vapor, right? I feel like we're kind of in like the Wright brother era, right? Before flight, or basically like, what, two people flew that day and now millions fly every day. But lithium discoveries and financial prowess are proving that they're already happening every day. As we're about to get into in a second, some hard numbers, because I know there are some people in here like me who are angel investors and they're like, hey, how can I get paid? And I get it. So this slide is dense on purpose, right? Because quantum is not just one company, one lab, it's an entire ecosystem, right? You'll see over here to the left, the users, finance, pharma, aerospace, life sciences, your Goldmans of the world, Merck, Airbus, et cetera, et cetera. Next, applications, optimization, chemistry, simulation in here, right? Providers. Hold on, let me move this over here, right? Providers, right? And like basically qubit makers, essentially, right? And then there's hardware folks who just make cryogenics just to cool qubits, like we just showed. So this is not just for physicists, right? It really reminds me of the early internet map, like messy, fragmented, full of players. But what this shows to me is like momentum, right? Every sector, every stack layer is being filled in. Startups are here, Fortune 500s are here, cloud giants are here, and that should really tell you that quantum isn't isolated anymore. It's an industry. Maybe there are some MBAs in here and they're like, poppycock, Nolan, we want more numbers. Okay. If you think it's hype, follow the money, right? Global effort, $55 billion. The US is leading at 7.6 billion here, but China, our friends, are 15 billion. So remember that gamble that I told you earlier? But as you can see, there's rising players like Canada, Israel, Singapore, right? This isn't a regional play, it's a global race, like I was saying earlier. It reminds me of when the world was Carmen San Diego, except for they're chasing building quantum, right? Entire nations don't pour billions into hype. It's about national security, economic leadership, right? And so, all over the world, right? Luanza, my God, this is your time. Right? Look at what's going on with the Quantum Prairie Initiative in Chicago. 60 billion projected over the next decade, 50,000 jobs created, trained, and 200 companies expected to join the region. And then there's significant planned investment, 625 million in capital and 70 million in tech hub funding. To me, this is reminiscent of Silicon Valley in the 1970s, right? I probably should mention I was originally a history major too, and I try to fuse these things together. This is that moment, right? But for quantum, and it's centered right there in Chicago with Luanza, right? So if I were looking in the future as a physics major, right? That's where I would probably go. And we need more engineers as well. And as I keep screaming from the rooftop, AI researchers. So almost getting to questions and answers. We're running out of time. Okay, cool. If you only remember three things from this talk, let it be this. Stay curious. It's like a spark. Stay adaptable. It's like the wind, and stay credible, right? Cut through the hype, but learn to speak. And hopefully I gave you some quantum to speak fluently, and you can dive into it and educate yourself more about it as well. And we don't want our people just surviving in the quantum era. We want our people leading it, right? And quantum's just not for profit. Like Luanza said, it should be for the people, but we have to learn it first. And what was discouraging to me, like I said, when I spoke to the folks at the dual degree folks in Morehouse, physics, the engineering, what have you, who don't know about this, we need that talent in it. If I can make it with my background, they can sure as hell do it with theirs, right? So you're seeing it now in sustainability, healthcare, well-being, right? And so I think that we're at the dawn of a new era and we don't want to miss it. Think about standing in the age of like flickering light bulbs when Edison stole it, right? You would know one day that the cities will be illuminated, and that's where we are with quantum. So here's my question to you. Where do you see yourself in the story? And I'd be happy to take any questions. Thank you.
Okay, this is Lawanza. Glad to see you talked about Chicago and its being a launch pad for the quantum computing. You know what I'm bringing up? I'm in the process of starting an analytical chemistry lab. I attend the world's mining conferences where they mine for lithium and gold. I came from out of the electroplating industry analyzing metals. Now I'm a software developer. Um, I'd like to talk with you in more detail, and I'm asking if you'd be interested in partnering with me. Like to begin to introduce quantum computing in some of the laboratory work that I'm going to be doing. I may have my laboratory at IIT. I used to be on staff during their chemistry and chemical engineering department back in the late 80s and early 90s, okay?
So I took from that, the question is, do you want to partner in quantum computing? Sure. Let's talk about it. And I think that, and let's talk more Ashley and Blevity crew, because I want to consult more also, because the more and more I go around, I was in DC last week for the Congressional Black Caucus stuff. People don't know as much as AI as they think, and I don't want people to get cheated. So I definitely want to do more consulting and mentoring in that realm. I used to do it for Microsoft for startups for free, and I did it for hundreds of CEOs. Why not do this for us, right? So, yes, we will share information, Luwanza,
Thank you.
and talk when I finally get out of demo land, because everybody wants a demo in the UN these. Next question, please.
Hi, good day. My name is Ty. Oh, how would you want to do this? I also raised my digital hand. I don't want to talk over anyone who's also trying to ask a question.
Oh, my bad. I forgot you can call them. Again, sorry, folks. You know I don't use Zoom much. Yeah, shout out to Microsoft Teams. Yes, you are next, ma'am. Who was talking?
Ty, go for it.
Yeah.
Thank you, Ashley. Thank you, Nolan. My name is Ty, and I'm the founder and CEO of a future of workplace productivity SaaS called Organizely. Last year, my team and I developed a proprietary AI engine that I call Process, which converts actually transforms current state documents into future state documents. So we're getting ready to release another version that will transform any documents into process maps, business outlines, or swim lanes to operationalize what you're doing with no manual input. I've been following quantum computing, quantum neural networks now for about a year and a half, and I do have a colleague that I want to work with in order to move forward. How and where can I find the resources to adequately continue to educate myself in order to be able to vet engineers to work with? So that is my question. I will give you a little bit more context if you'd like it, but I want to make sure I reserve time for other questions. But it's more about.
Sorry to cut you off. Yeah, yes, and I have so many questions. You know, I'm a former architect. So if you're doing AI and you say proprietary, that means you're in the cloud. Which one, how you set up, which architecture like, things like that. That's where my mind immediately went. To your question, I put quite a few resources there at the top. I don't, Blevity folks, can you pin it or something?
I grabbed it. Ashley
yeah.
put it up there. I grabbed it and I opened it so to have it for later on. But in terms of vetting engineers, because I'm knowledgeable and I'm going to sessions like these, I'm a software engineer that no longer works as a software engineer. And I'm bifurcating my product right now because the DoD has interest, and I'll stop there. So I need to like really formulate what that looks like from the compliance side, because the minute you have process, it also leads to compliance and audit. So I'm building out that product process to fully streamline those things. And quantum neural networks is like my next step. It's on my 18 to 24-month roadmap. But how do I evaluate engineers? Thank you.
So the point I was getting, yes, Ann. The point I was getting to is I have mentees and I when I sold the company, I was working with the African Leadership University out in Rwanda, and I gave them the IBM portal that I provided you guys. They taught themselves Q sharp, and next thing you know, they were doing quantum machine learning. I say this to say that, my friend, I know as an ex-engineer, you can educate yourself. And the best way to vet an engineer, which I believe was the question, is to teach yourself, learn it, and then see whether they're talking about is poppycock or not. You don't want the stochastic parrot of an LLM to depend on. You want to depend on the original artificial intelligence, which of course is your synaptic space in your brain.
Thank you again, Nolan.
If I may, I'm a former quantum advisor
Oh.
from like 4 or 5 years ago, but I currently work in private equity and I do diligence for tech companies, and we're starting to see a handful of quantum firms come in. So I'm happy to help provide diligence either on engineers or product or whatever the case may be.
Awesome. Could you put your information in the chat? Thank you.
Yes, sir. Who was that speaking? Yeah, shout it out.
That's
For
Wayne.
real.
I spoke earlier.
Okay. Okay. Thanks, Wayne.
Sure. I'll just have my LinkedIn.
Okay. And I'm going to repost the resource links for someone's request I saw. Oh, by the way, I think you have to add my email in on LinkedIn. Just look at me and I'll add you. I'll find you. Sorry, Marcus, you're up next.
All good, all good. Hi, my name is Marcus. Background AI research, own a company, blah, blah, blah. But so I've done some advising for some companies that were in quantum computing. And what I was seeing was like the only applications of like their chips were like being better at like sampling problems, right? And then from my past experience of like using like IBM Qiskit or like TensorFlow Quantum, like the only thing you could really build are like toy models that are like worse than classical machine learning models. Like, is there some sort of use case that's like useful that we should be thinking of? Like, these are the next things to be building that you could currently build with today's technology.
I think that, and I kind of skipped it because I didn't have a slide for it because it just came out, what, 2 days ago? But the IBM Vanguard use case to me is interesting in finance, right? Because now we talk about a benchmark to reach, right? As opposed to, well, we might get this energy and look, now we're at 1,000 qubits. And basically, to your point, it's like, so what? Like, how can I use that to build something today? But I think that if we're talking about something with finance, finance is unstable. Qubits are inherently unstable. But if we can figure out a way, if this benchmark that I put in here holds, right? And we can find out a way to accurately introduce it into finance, I think sky's the limit. If that answers your question, it's something that you can build right now. And I build apps still all the time for fun. It's kind of like stress relief, I guess.
You're saying that most of the opportunities like in probabilistic machine learning kind of.
Correct.
Okay,
yes,
cool.
in quantum machine learning, for sure.
Cool.
Yes.
Thank you.
Let's because I have maybe I can go to 505. It's Black and Tech is in town and Amazon's having something, and I have some solution architects to interrogate. I'm taking their professional exam next week, and I just love the way they approach problems. Anyway, Melissa, you are up next.
Thank you so much. Shout out to Ashley for responding to my request so timely for this course. I wanted to know, I had a couple of very quick questions. Number one, is Q Sharp agnostic or is it a specific language to Microsoft?
It's open source.
Okay.
It's funny in that video, the only thing I paid attention to was Q Sharp and Python. I'm like, ooh, why would I do anything else?
Okay, and then also, is the deck being made available afterwards?
Ooh, let me double check on that one with the legal folks.
Okay, if not, there was a slide you showed that showed the different ways quantum was being used by the different customers. Are you willing to re-display that slide?
Sure.
And lastly, you mentioned Microsoft leasing quantum through Azure. Was that correct?
Well, you as a customer would be sure.
Okay, so is that product a competitor to IBM's Quantum Guardian products?
Yes.
Okay. Yes. That's it. Thank you so much. Those were all of my questions. Thank you so much, Nolan.
No problem. Happy to help. Do you have it so I can stop sharing? Or do you need me to keep it up?
I got it. Thank you so
Okay.
much.
Cool beans. All right. Brianna, you're up next.
Yes, so I have a quick question. So I am a senior engineer at Dell Technologies. I work on basically the infrastructure, so anything within a data center. Before that, I was a network engineer, and I just finished up a data science certificate course through MIT. So I wanted to know, as far as like with my background in obviously infrastructure engineer, um, what would be some ways that I can, or what would be my next step in my career path to be more appealing for the roles within the quantum computing space?
Ooh, do I have good news for you? You said one important word out of all that I heard. Infrastructure. Right? Which is why I'm going to interrogate these folks because it makes so much sense to me. I don't care what you do. I don't care if you send a robot into space, you have to connect A to B, right?
Yes.
And as these models get more commoditized and things of that nature, infrastructure is going to be what's going to be the sort of product differentiator, right? So I would say AI infrastructure, perhaps.
Okay.
Cybersecurity, quantum safe cryptography. Yeah. You have a multitude, and I say this to everyone, by the way, my mentees, everyone. Start with infrastructure as your foundation, right? Because you can take it in so many places. I have boys started that who are working for Palo Alto and Red Hat and other places like that, and they never seem to run out of employment. So people say that cybersecurity and things like that, you can go into cybersecurity with a background in infrastructure. So I think that's the foundation to be, and you're in a very, very good place.
Okay. So just continue to focus on infrastructure. That's basically what I
Yes,
do. Yeah. Okay.
but the AI infrastructure.
AI infrastructure. Understood. Yeah.
Let's be clear,
Yes.
because it's so. And I'm going to leave you guys with this. It's so interesting that I talk about all this fine tuning and parameters and models, and no one wants to talk about governance, data security, data ingestion, the important things, right? So, like I said, you're in a very good place.
All right. Thank you so much.
All right.
Thank you so much, Nolan. This has been an amazing session. I can see in the comments that we all feel the same. So thank you again, Nolan. If you have any questions, yeah, connect with Nolan. On Nolan, I know you dropped your LinkedIn, but you said that they needed an email. So what was the
Yeah,
instruction?
email. Just look me up and I'll find you. If you want to send me an email, that works too. But as long as you look at my profile, I'll find you.
Okay, perfect. Well, everyone have an amazing rest of their day and week and weekend, and we'll see you soon.
Thanks, guys.